right, Unit 2, Day 6, polynomial. So we've been working with polynomials for a lot. All the quadratics are polynomials. We solve them a variety of ways. Today we're going to do polynomial inequalities. I don't know that we've done inequalities in here. That's the less than or equal to, greater than or equal to. Open circles and closed circles. Number lines, intervals, shading, all that stuff. So let's do another one of these where I'll list the steps while we work the problem. Again, this is, I think, old news for you, but I guess we'll find out. So x squared minus 3x is less than or equal to 28. All right, step 1. Find the zeros, or the roots, or the solutions, or the x-intercepts, whatever you want to call it. That's what Friday's worksheet was finding zeros of quadratics. So let's move the 28 over. I guess unless we wanted to do complete the square, but nobody does that of their own choosing, generally speaking. And then for finding the zeros, I don't really care about the less than or greater than. We'll worry about that later. Let's just set it equal to 0 and figure out what the zeros are. So we'll change it to equals. Know that that's not exactly the problem, but this is how we're going to get toward the answer. All right, this one will factor. And in fact, I think all of the ones today will factor. So that makes life a little bit easier for you. But assuming you can factor, of course. Let's see, 28, multiply to negative 28, add to negative 3. So 7 and 4 with a minus 7 and a plus 4. All right, the double smiley face checks the middle term. Negative 7x plus 4x, negative 3x. So x equals negative 4, x equals 7. So find the zeros, step 1, but step 1 might be several lines long. It's not like just one thing. It takes a little bit of work to find the zeros. Step 2 is with those zeros, set up a number line. Some people go overboard with their number line. I don't need, or you don't need, to put 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1, negative 2, negative 3. You don't need to do all that. You can get by with just putting the numbers you found on the number line. That's fine. You do got to make sure they're in the right place, right? If it's negative, it's over on the left. So negative 4 would have to be over here. 7 would be over there. Are those going to be open circles or closed circles? Do you remember? Closed. Why closed? Because of this equal to way back here. So be careful about that. If that one wasn't equal to, then it'd be open circles. But the equal to part of that means closed circles. So closed at 7, closed at 4. Closed meaning we want to include them, meaning they work. So our number line is set up. Now let's test the intervals. All right, when we set up our number line, this one created 1, 2, 3 separate intervals. Depending on the problem, you could have 2 separate intervals. You could have more than 3. I don't think we'll have more than 3. So we'll have 2 or 3 intervals. And to test them, I need to pick a number in each interval. So some people, this is the only place they mess up. They pick a number that's not in the interval. So, I mean, maybe that seems silly. It's supposed to be the easy part, but what's a number less than negative 4? Negative 5. And I think some people get confused because they think, oh, less than 4, like 3, 2, 1. Well, yes, but no, if we're in the negatives, and here's where a number line helps, like headed this way, negative 5 is over there. What's a nice number between negative 4 and 7? 0. Like you can pick negative 3 or 6, but 0 would be the easiest choice. And then a number bigger than 7, I'm going to go with 8, but you could go with 9 or 10 or 5 million. Any number you like, you can pick. Because these numbers are sort of representative of the whole interval. So if that negative 5 works, it means everything on that interval works. If 0 works, everything with 0 works. If 8 works, everything with 8 works. So I don't have to test everything. I just need to test one representative from each interval. And when we say test, we need to test all the way back in the original. There's some ways to kind of skirt that, but the easiest way, the best way, the safest way is to go back to the original and see what happens. So negative 5 squared minus 3 times negative 5 is less than or equal to 28. And we just want to see if that's true or not, because if it's true, then we're good. We'll shade there. If it's not true, then we have to kick it out, and that interval is no good. So 25 plus 15 is less than or equal to 28. And you don't really have to work the whole thing. As soon as you figure out whether it's good or bad, you can stop. 25 plus 15 is not less than 28. So that's a no. I'm going to put an X there. I'm not going to shade there. All right, let's plug in 0. This should be an easy one. 0 squared minus 3 times 0 is less than or equal to 28. Yes. Yes, it is. 0 is less than 28. So that's a yes. That's a check. That means I can shade everything in that interval. And then lastly, we'll check 8. 8 squared minus 3 times 8 is less than or equal to 28. 64 minus 24. 40 is less than or equal to 28. No, it is not. So that's a no on that end as well. So we tested the intervals. We know where our answer is. So here's a picture of our answer, but we want our answer, step 4. We want our answer in interval notation. And going from a picture to interval notation is usually one of the easier things, because you just read the number line left to right. Our solutions start at negative 4 and they end at 7. Parentheses or brackets on those? Oh, I thought I heard both. Brackets though. Why brackets? Because we want to include it. We want it. The closed circle goes with the brackets. We want to include them. So we want to include our answers. So negative 4 to 7 with brackets. I'm going to give you the worksheet, but I'll say it now. Let's omit number 3. Because I don't know how you would work number 3. So let's omit number 3. In fact, why don't you try number 2? Try number 2. same page. You can move that over as long as you preserve that inequality. Okay. You can move things around. Okay. So yeah, if it helps you to move the 38 over, you can do that. Yeah, perfect. Thank you. All right, let's finish number 2 here. So move the 8 over to get it equal to 0 so that you can find the zeros. That's step 1, find the zeros. We can even do abbreviated notes here. Zeros, and then number line, and then intervals, and then interval notation. So there's today's notes in four lines right there. So x equals 5 and x equals 6. I saw a lot of you tested 0. You could test 4, you could test 3, you could test -7, but 0 is always a good choice to test, as long as you test it in the right interval. Greater than 6, look like most of you tested 7. And in between 5 and 6, you don't have very many options. Well, I mean, I guess you still have an infinite number of options, but you don't have very many good options. And then testing it, you can test it in the original. You can move things around a little bit and test it in the in one of the succeeding steps. I said test in the original, but you can really, and sometimes it's easier even to test in the factored form, as long as you kept the inequality. In fact, testing, as long as you know you factored right, testing in the factored form is easy because then it's just negatives and positives. So if I plug in 0, I get negative times negative is positive. That's greater than 0, so that works. Oops, I forgot about open circles and closed circles. both open because we're not equal to. 5.5 is a great example of where testing in the factored form would be a little bit easier, because 5.5 minus 5 would be positive, 5.5 minus 6 would be negative. Negative times positive is not greater than 0. And then plugging in 7. 7 minus 5 is 2. 7 minus 6 is 1. And 2 is greater than 0. Yes, yes it is. And then translate your picture to an interval notation. So you read your solutions from left to right. Negative infinity up to 5. Parentheses. Union with 6 to infinity. That means that almost everything works, right? Everything except between 5 and 6 works in that inequality. Questions on that one? All right, next one I want you to try is number 6. Oop, kind of got it started there for you. So try number 6. Okay, so move the 20 over, factor it. A little bit odd because it has the same factors, which means it has the same 0, which means it has a double root there, or multiplicity of 2. It's got this 1 point that we're going to put on the number line, which is different, but I guess in some ways easier because now there's only 2 intervals to check. So let's check 0. And again, you can check it into the original or you can check it into the factored form. 0 is always easiest to check into the original because you're going to get 0 minus 0 plus 21 is greater than 20. Well, yes, 21 is greater than 20. That's true. And then if we check 1, 1's pretty easy. Again, you can check it in the original or you could check it in the factored. I'll check it in the factored just to mix things up. 1 times 1 is greater than 0. Yes, yes it is. So I shade on that side as well. So that's a little bit odd. So if I read my number line left to right, my solutions start at negative infinity. And we thought they were going to stop at 1/2, but we include 1/2 and we go on forever. So it's just negative infinity to positive infinity. That means everything, any number you plug into this equation is going to work. It seems a little bit of an odd problem, but that's why we did it, because it's a little bit of an odd problem. One more final reminder hint, and that is there's a pattern to these things that you may not appreciate yet. The first one we did, only the middle was shaded, so it was no, yes, no, it alternated. And then we did number 2, and it was yes, no, yes, that one alternated. So the trick is, or the hint is, they usually alternate. The only time they don't alternate is when there's a double root. You don't have to remember that. Like if you just test the intervals, it'll work out that way every time. But if that's something that sticks in your brain, it kind of provides a check at the end of the problem. Like they should alternate. The only time they don't alternate is when something goofy is going on, like number 6. All right, so your assignment is the rest of the worksheet. Omit number 3, because I don't know how to factor number 3. I think somebody made a mistake on that one. So throw out number 3, but the rest are quadratics. They all factor, and so they're all pretty straightforward. And we'll answer questions on those tomorrow.